Welcome to the second part of tutorial 10. I want to start this tutorial by giving a huge thank you to everyone who voted in the poll on computer use. I was very impressed by the amount of people who showed up to actually weigh in, voice their opinion. Hopefully this information will go to improving the course for future students and improving future courses for yourself. Today we'll focus on some of the contents that we've been talking about this week, so Gen, RAM, and then how they work together. Here's the big picture idea of what Gen does. We want to build a possibly lazy list of the following form. Some list one information appended to another list, and that other list is some list two information appended to yet another list, and it's lists all the way down. The gen function that we have provided on the assignment page in gen.racket is an actualization of this in Lazy Racket. So here's the code, gen imp state step. It takes 3 parameters. You can see I've copy and pasted this idea of gen, but slightly modified it. I have renamed these parameters. It was actually a student that suggested this on Piazza to make it a little bit more readable, improve kind of what this is saying. And it might help you after it almost makes more sense to look at an example first, such as these examples in the lecture, and then come back to this definition and see what it does, because it's a little bit opaque, this definition. And what it does ultimately is it calls step on the input, the state, and the continuation function. And in your calling of gen, you'll have an input, a state, and then some step function. And the step function will either return empty or it'll return a call to the continuation function on a modified input, a modified state, and a list. And that list here is out. And the modified input is what's going to get passed in as new input. The modified state is new state. Out is the list. And all that happens is the out is appended to a recursive call, a tail recursive call to gen with the new input, new state, and step. It's allowed to be used on A11. I think that it simplifies the thinking that you need to do on A11 a little bit if you use gen, but you're free to not use gen. And the reason why I think it simplifies the thinking is because then you can think about the history as an input stream, about the state as whatever computational data you might be keeping about your own past moves, about how much you've won and lost, about what moves lost which games, and all that kind of stuff as you try to build a champion that can beat Maggie, Bart, Lisa, and the stranger. Another tip here is that gen is, as defined in the gen.rkt, is a lazy racket function. So if you're testing this in strict racket, like on A12, you might want to copy paste the information from gen into the start of your file instead of calling it from the using require, because the require definitions in lazy racket and your A12 will be in full racket, and that is strict full racket, so non-lazy. And you don't want to have to stare down a million promises. It will be much simpler just to get this information computed, because you'll be working with lists of finite length, and then you can comment at gen when you go to submit your program. What about RAM? It's something that we've introduced this week. And the idea behind RAM is that it's an ADT, and it's a fairly simple ADT. There are only 2 operations, RAM store and RAM fetch. And RAM store, you're going to put information into the RAM, and you'll put RAM information, you'll specify the address and the value. So you'll see that RAM store has 3 parameters, a RAM, and then 2 numbers. The first one's the address and then the value. I'm going to store a value of 4 at address 0. That's what's being depicted in this first column right here. RAM fetch is kind of the opposite. I'm going to give it an address and I'm going to see what's the value. So if I RAM fetched with this RAM and 0, it would give me out 4. We also, to actually use this in practice, you need an empty RAM that you start on, and core dump is provided for debugging. Core dump is a function in ram.arcat, and it will simply print out all of the addresses and their contents. Here is a possible visualization of RAM, and this is probably the most common way to think about it. It's just a list of addresses, and they're each associated with a number. Again, this is one of the most simple schemes of computation possible, and although simple, it still offers a lot of flexibility. I want to talk about what happens when RAM meets Gen now. So in A12, we ask you to use RAM and Gen to compute information about some lists of numbers. The kind of first big problem to do is to take a list of numbers and then sum them all and accumulate that sum. Every step has to be O1. Sorry, I kind of rolled straight into the tips, but I want to do a little bit more background. Is that on A12, we give you Gen and we give you RAM. We don't really give you Gen. You give you Gen from our Gen. And we ask you to write a program using Gen. But that program, you actually only get to define the start and the step function. And then we will provide the list and call Gen on list, and then the start and the step function that you provide, and see what happens. So when you define your step function, every call to step has to take constant time. So this means that if you want to traverse a list, for example, you are not allowed to under this constraint. You actually just have to traverse one element of the list. And a common example would be if you have some kind of list and you want to check if a number is in that list. What you need to do is go through and check the first. How you normally do this is with your list is check against the first element, the second element, third, fourth, fifth, sixth, and so on until you get to the end or you find it. If you get to the end, it's not there, and if you find it, then it's there. No such thing is possible with the specification of A12. You have to step through your list one element at a time. So that's a tip. Any kind of folding, any kind of thing that would take n operations, you can't outsource to helper functions. You can't do all of this kind of stuff. You just have to do it one step at a time. A little bit of an aside, you can't outsource to helper functions permitted that they're ON. Addresses and values must not be negative. For example, you can't store -1 to say that you're at the end of your linked list, for example, if you wanted to do something like that. You can't access a negative value. The RAMs, you can't store 0 at 0. You can store zeros in it, and you can store at address of 0. We kind of use the computer science definition of the naturals, where you include 0, 1, 2, 3, 4, 5, and so on. To do this assignment with the RAM and the machine language especially, I would recommend getting a pen and paper, drawing a RAM like in this picture, and just kind of underline 0, 1, 2, 3, 4, 5, 6, 7, maybe up to 8, and then seeing if you want to set aside some of your first few addresses. For example, set aside an address to keep the cumulative sum, set aside an address to keep a pointer to a linked list, set aside an address to do whatever you want to do, whatever kind of natural operation you want to do. And then for addresses 8 onwards or addresses 4 onwards, for example, use all of that information for your actual linked list, your actual array, for your actual try, whatever kind of data structure that you want to have, just in all of the rest of the RAM. But just keep a little bit of it for yourself, for computation. I've got some very simple practice problems, maybe not simple, but simpler than some of the practice. And it's just 2 little exercises to get you warmed up for A12. The first one is to write a program with RAM and Gen under the same constraints. So that means you just provide start and you just provide step, and step has to be O1. That just returns the cumulative sum of a list without ignoring duplicates, just sum 1, 2, 3, 4, 5, just to get yourself used to storing things in Gen and retrieving them, and kind of just doing one of the simplest RAM Gen interactions possible. The next one is to write a program that follows the same constraints as assignment 12, of course, and implements storing a list of things in a RAM. Of course, it's only a list of numbers because you can't put anything else into a RAM, and you are free to use your dealer's choice of array style, linked list style, trie style, whatever you think you want to go for this time. Hopefully you have some fun with it, express your own programming creativity, and test the limits of what you can do a little bit. Thanks for watching the video, and if this is the last time I get to see you in this one-sided conversation in this tutorial way, I'm really happy to have been an ISA for all of you. It's been a really wild ride over these past 4 months. Good luck on the final to everyone, and I hope that you come out of this course having learned something. Thanks again, and hopefully we'll chat sometime in tutorials, office hours, not tutorials, I guess, email, Piazza, whatever. The whole course staff everyone is happy to talk to you. So I'll see you next time, and bye for now.